Okay, welcome back to our podcast series called Lime Time in Texas. My name is Dale Rand. I'm the Executive Director of the Lime Association of Texas, and today I have a special guest with me, Kevin Ingram, and this is part 4 of a 4-part series that we're doing on basically just asking an expert. And so I'm going to first let Kevin talk about his background and his expertise in chemistry and the use of lime.
Well, thank you, Dale. I have a PhD in chemistry from the University of North Texas. It was more industrial based. Our group did lime in binders for refuse derived fuel. We did cements, we did fly ashes. So really applicable here. I've been in the lime industry for almost 32 years now in R&D, technical service, and NBD.
Okay, great. Well, I'm going to start right into some questions. This fourth part of this podcast series, I'm going to talk about the use of lime in hot mix, both as an anti-stripping additive and as just a mix performance enhancer. So my background was in asphalt pavements, so I spent over 26 years with TxDOT. It tested a lot of asphalt hot mixtures in the lab, ran a lot of Hamburg wheel testing, and so I saw a lot of results in the lab of how effective that lime was in improving the performance of hot mix, and was actually able to do some long-term studies on field performance where we saw that lime was a very effective and to basically prevent stripping in the field, which stripping is basically lack of adhesion between the asphalt and the additive and the asphalt and the aggregate. And so I want maybe to ask Kevin here, the chemistry, I know that lime works great in hot mix. I don't understand completely why the chemistry of that, what it does. Is that just strictly as a mineral filler, or is it some chemistry going on there?
Well, there's multiple things lime can do. Let's first talk about the anti-strip. Why would it work? Well, if you get a good limestone aggregate, there's no problem. You typically have problems in siliceous aggregates. Well, why is that? Silicates tend to have a negative surface charge, okay? The asphalt itself is the bottom of the barrel. They've already fractured everything they can off of it. It's the oil that's left over. There's a lot of functional groups that have oxygen in there, and that has negative surface charges. So you get a rock, you get some with negative charges, you get negative charges here. Yeah, it's still going to be sticky, but there's a lot more repulsive forces in there. So it gives you a lot of deflection in there. Well, what's the problem there? Water. Water's in nature, it gets in there, you start going over, it starts to pump, you make an emulsion, it strips. So it's all about, you have to do something to get rid of that negative charge. You put lime on there. Let's say you put it, some states require lime on the aggregate. What happens, it gets on there, it forms a very, very thin coat, it recarbonates rapidly, and all of a sudden it's like having an M&M coating of limestone on the outside. It's a neutral to slightly positive charge. Neutral, positive, negative, it grabs a hold. And so your anti-stripping is all due to a chemical physical effect. You're putting in a chemical, it's reacting, and you're making a physical barrier there. So that's why it works so well in anti-strip.
Okay. I know, and I know just my experience was we used a lot of siliceous aggregates out of South Texas, which tend to be, they're crushed gravels, but a lot of times they weren't crushed that well. They were sub-rounded, and then a lot of times also they still had clay coating on it. Some of them tend to be dirty. They're not washed aggregates. So does that lime react with that clay that's in there?
No, absolutely. And we see this in different parts of the country where the best aggregates tend to go in concrete because they're clean. Stuff going into roads, people are, we'll just use it. The problem is there's going to be clays. You have rock there, whenever you crush it, it's going to tend to break along the weakest plane, and anywhere if there's a little bit of clay inclusion, it's going to break open. That clay is now available to be out. Well, you get clay, it's really small, you start to try to grab a hold of it, it slips. And so lime will treat it, it'll do the cation exchange, and over time it will do a pozzolanic reaction and gets that clay from being a clay into being part of the system, cementing it down.
I always knew that lime worked. I just didn't understand. I just didn't fully understand how that chemistry works in there. So one of the other questions I get, so we typically, when I ran Hamburg wheel testing, I always saw that the rut depth, it improved significantly when I used, most of the time, almost always, say at least 90% of the time, you get significant resistance to rutting when I put lime in there. Typically, we'd add about 1% lime. Sometimes I would hear people have the concerns of, is the lime making that mix too stiff? Is it going to be brittle and prone to cracking failure? So how does
Well, I will say if you add too much, it's going to be a problem. Well, so let's just go back in. Let's do a cooking analogy. You're making a gravy. You're trying to make it thicker. What do? You throw in flour. It thickens it up rather quickly. It's all about a physical effect. Well, why wouldn't something else work just as well? A hydrated lime, which is what you're using here, has a particle size on average of about 5 microns. Really, really small. Other stuff's bigger. So let's say you put in sand. Hey, we're going to stiffen this up with sand. The difference between 5 micron and 50 is 10, but there's 1,000 more particles if you have the same density in there. So you get more particles. It's just about that physical particles here. Your asphalt's trying to move around it. There's just stuff blocking the way. Now, when can it be too thick or too stiff? Well, let's start talking about 2, 3, 4% hydrate. What happens then? Well, hydrated lime is going to have about 20 square meters per gram surface area. All those oils, you got positive here on the lime, you got negatives in your oils from the asphalt, it's going to want to absorb. You start sucking the liquid out of the system. So it starts getting too thick if you get too much lime, and it sucks the oil out. So there's not oil there for it to keep its flexibility. So that's where you have the problem. So I always say when in doubt, add lime, but no, add too much. There is an optimum amount.
I know that 5%, but I know from firsthand experience, 5% is too much, because when I used to design, I've designed, over 300 HMA mixed designs, and I doing an SMA design one time, we didn't have fly ash. So we decided we're just going to add more lime to it. We typically add about 1%, and we tried to add 5% in the bucket mixture that we were using. It actually got so stiff that the whole bucket just stopped turning. It was it set up in it. So yes, I would agree with you that 1 to 1.5% is probably the maximum that you typically want to use of a hydrated lime at least. So. And
what you learned there, you didn't tell everyone else in the country, because I've talked to someone else in the last year, a researcher, that was trying to do 3 or 4 and couldn't figure out why it didn't work.
It gets extremely stiff. Yeah. So, and I've seen some research also along the lines of cracking. I don't understand the micro cracking or whatever. I know Peter Sabali did a study out at University of Nevada, Reno, correct? And looking at that lime actually helps prevent the age hardening, which is, I'm going to say for the average person, is counterintuitive. Most people think lime, it's going to stiffen it up, it's going to be more brittle, it's going to crack sooner. And that's really not the case. I mean, it's what the research has shown.
So let's just go back to something simple again. We put enough physical material in there, it makes it stiffer. But that's all it's doing. But over time, you have a positive surface on this calcium hydroxide. Negative charges come in, so let's say we have carboxylic acids on that asphalt. It reacts with the lime, we make a calcium salt there. All of a sudden, it's more neutral. You don't have that negative charge on that oxygen react, or hey, I'm here. Well, what does that do? It allows, if you still had that oxygen there, you have regular neat asphalt, oxygen from the air can come in and attack there, because it's, hey, I'm pulling the electrons toward me. There's a way, this oxygen will attack on the backside, and you get breakdown products occurring. So age hardening is all about oxidative age hardening. It's all about reacting the asphalt and the different groups in there with oxygen. And when that happens, you change the structure, you break it down, you put extra stuff in there, and all of a sudden it gets like an old man on a cold day. It gets sort of, all the joints hurt. It doesn't want to move and flex.
Okay, good. I only have one final question for Kevin now, and since he's an ex-college professor, I've got to ask you, discussing all this chemistry, is any of this going to be on the test?
Yes, it is.
Because if it is, I'm going to have to go back and review the podcast series myself before I'm able to take that test. Well, we want to thank everybody for your time today, and hopefully you've learned a little bit about using lime in hot mix application. It's one of the, actually going back to, I've been doing it 35 plus years, and lime used to be the the go-to additive in all hot mix application if you were concerned about stripping. Now there's some other products that have come along that do something, warm mix additives and some liquid anti-stripping additives, but my experience has been nothing works better. As a general rule, lime works better, is more effective than almost any of these other products I've ever seen.
One thing to add there, the other anti-strips, they're easier to use. That's why people like them. If you go through one freeze-thaw cycle, they hold up okay. Lime can go through 5 or 10 freeze-thaw cycles and last. And that just shows you the durability. The liquids can't.
Yeah, it's interesting you bring that up because about 2 years ago, I was able to go to Yellowstone National Park and visit with them about the roads, pavements there. One of the things they said, and they have I don't know exactly what the aggregate is, but it's a very hard, siliceous, I guess it's volcanic rock, I don't know.
I'm sure.
But one of the problems they had was the liquid anti-strips just didn't perform as well. So they had gone to using 100% liquid additives, and then they went back to using lime, and they said it just performed better with the freeze-thaw cycles and the rugged environment they had there. They used 100% in the national park there as using lime as an anti-strip and as a mixed performance enhancer in those applications. So I was kind of a real live example. So.
Utah DOT, Utah's mandated use of lime as anti-strip. 2 years ago, they published a report, retrospective on how did roads actually work, and then doing more lab work in the lab, and they're standing by using lime for anti-strip. And the report's available online. We can get it for you because it is time and new research, checking new different additives, and lime still is the best.
Yeah, very good, very good. In my personal experience, I think it was 1993, I think one of the first research things I did at TxDOT, we did a study on Northeast Texas pavements that had a lot of stripping problems, and the ones that used lime far outperformed the ones that did not use lime. And that's a lot of I'm going to say some of that sandstone gravel coming in from Oklahoma and Arkansas, and some of the harder, more durable aggregates, but they were prone to stripping. So very interesting that I think lime's kind of a time-tested product in the use of hot mix. So. Well, if you got any questions for either Kevin or myself, please feel free to submit those questions to us. We'll be glad to get back with you with the answer. And you can submit those through the website or call me directly or email me at dalerand@limetexas.org. And we really appreciate you taking the time to join us today. Thank you.
Thank you, Dale.
Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn and subscribe to our YouTube channel. Thank you for watching.